Hi everyone. So in this video, we are going to see more operations on the partition matrix, right? So we have already seen the introduction to the partition matrix or the block matrix and multiplication of the block matrices, right? So these operations we have already seen that how to multiply the block matrices and how to do some other operations. This is what we are going to see now, okay, in this particular session. Okay. So we will cover some more operations in this particular session, right? In this particular session, we will cover some more operations. So now let's get started. Okay, before I start, let's just solve this question. Can you solve this question? So what they are saying that suppose there is a block matrix which is this that is making sense where A is P cross Q. What is the dimension of C? So if A is P cross Q, which means there are P rows. Okay, so which means there are P rows and Q columns. So this is A. This is P, this is Q. Now what they are saying is that there is some I. Okay, now you tell me what is the dimension of I? Number of columns could be anything, but the dimension of I must be the number of rows must be P, right? So columns, let's suppose I don't know. Okay, so columns could be anything, but these rows must be P. Okay, this is I. Now what about this I? Here in this I, columns must be Q. Rows could be anything, right? So any number of rows, but columns must be Q for this I. Now, for this matrix, the number of columns, okay, do you know the number of columns here? So basically, here, see the columns here could be anything, right? So they are saying where A is a block matrix of P cross Q, and I. Okay, let me just check whether the dimension of I is also given or not, right? Okay, so I think the dimension of I should be given here. So if the dimension is not given, then what we can do, this is Q, number of columns are okay, but here the number of columns could be anything, right? Okay, so let me just check whether the dimensions are given in the original question or not. Okay, sorry, this I is identity matrix, right? Okay, sorry. So basically, if I is identity matrix, in that case, it will be the square matrix also. So here, if I know this is P, then do I know this? Yes, this is also P, right? If I know this is Q, do I know this? Yes, this is also Q. So which means because this must be the square matrix because this is identity matrix. So which means number of rows are Q and number of columns are P. So Q cross P, right? So it must be Q cross P, right? So the answer is Q cross P. Let's just check the answer here in the original source itself. Yeah, C is Q cross P, right? Now let's see the next question. Let's see the next question. This is the question. So what they're saying, assuming that it is a block matrix, right? Assuming that this is a block matrix. Now, what else they are saying? Which of the following must be true? Is this a square matrix? So I is square matrix because it is identity matrix. A is the matrix, right? Now, let's suppose A dimension is P cross Q. In that case, A transpose dimension, let's suppose A dimension is P cross Q. In that case, A transpose dimension will be Q cross P. So let's just quickly check all the other dimensions. So which means if one of the matrix is like this, which means if one of the matrix is Q cross P, so there are Q rows and P columns, right? So in that case, and this is identity matrix, must be square matrix. So the number of rows here must be Q only. If this is Q, then this must be Q, right? So we have identified that, okay, this is Q, this is P, this is Q, this is Q. Now here, A is saying that number of rows are P, number of columns are Q, right? So that's fine. So which means this is Q. Now the remaining, can you identify this remaining? What will the remaining thing here? This is basically number of rows must be P only because this is P. So this is P. Number of columns must be P, right? So this is P. So this is Q cross P, Q plus P, Q plus P cross Q plus P, right? So yes, this is a square matrix. So is this a square matrix? Then answer is yes. I hope you understood this, right? So this is yes, true. Let's just check the answer. So I have taken this question from this only. This is true, right? Okay. Now what about this? Is A a square matrix? Need not to be, right? It could be P plus Q, right? So this is false. It could be P cross Q. Is K symmetric? Okay, so this I'm keeping on hold because I haven't told you till now that how to transpose a block matrix. Okay, I will just tell you how to transpose a block matrix, right? I will tell you how to transpose a block matrix. And then we will see this. Now, the identity and zero sum matrices in K have the same dimensions. So they are saying this identity and zero. So zero is P cross P. Identity is Q cross Q. So that's why it is no. Okay, this is false. The zero sum matrix is a square. Is this zero sum matrix a square? So yes, this is P cross P. So this is true. Okay, this is easy question only. Now, let's just go to the next question. So what they're saying, suppose that B is 2 cross 5 matrix. Okay, there is some B which is 2 cross 5. C is 3 cross 4. Find the dimension of ADM, A, D, and M. Okay, so this is also I think easy. Can you try it? So what they're saying that B is having 2 cross 5, 2 rows and 5 columns. Okay. Can you tell me number of rows in A? It must be 2 rows only, right? Number of columns could be anything, but A dimension, this is 2. Number of columns could be anything here, right? So this is B, which is 2 cross 5. This is 5, this is 2. Now for A, I don't know number of columns. Number of columns could be anything. Now C is given to us as 3 cross 4. So which means there are 3 rows. And here number of columns are given, right? Here number of columns are given to be 4. If this is 4, then this must be 4, right? Okay. So basically, this is given to us, which is 4. And now they're asking about D. So this is C. Okay, this is C. Now they're asking about D also and A also. So they're asking about D. So can you tell me the dimension of D and A? This is A, this is D. So for A, what is number of columns? Can you tell me? Number of columns in A? It will be 4, right? It will be 4. Is this okay to everyone? Let me know. Okay, so it will be 4. And what about dimension of D? I think this must be 5 only. This must be 3, right? This must be 3. So what is the dimension of A? It is 4 cross 5. Sorry, 2 cross 4. It is 2 cross 4. What is the dimension of D? It is 3 rows and 5 columns. What is the dimension of M completely? This is 5 rows and 9 columns. Okay, so 2, 4, 3, 5, 5, 9. 2, 4, 3, 5, 5, 9. This is the answer, right? It was also easy and nice question. Okay, intuitive also. Now let's just move to the next question. This is also easy question. You just try this as a homework, right? I hope you can try it. Answer is on the next page. Okay, so remember this is identity matrix, which is a square matrix. Okay, remember if you are solving it, then this is identity and this is square matrix. Now let's just see this. What they are saying, compute the products shown in exercise 1 to 4. So basically they want to find out the product of these two matrices, product of these two matrices, product of these two. We know how to multiply two matrices, right? Two block matrices. Do you want to try this? Let's just try this quickly. So it will be I into A, which is A, right? The first element will be A. And then this will get multiplied with this. This will be B, I think, right? So this is A, this is B. Okay. Now you multiply this E and A. So it is EA plus C, and then EA plus D. So this is the answer. AB, EA plus C, EA plus D. This is also easy question, right? So that's why I did this. Remaining, this is homework. Okay, this is easy only. You can just try how to multiply two block matrices. We have already seen this. So these three you can do as an homework, right? Okay. Answer is on the next page. Okay. Now let's just see how to transpose a block matrix. Okay, how to transpose a block matrix. So suppose there is some block matrix which is given to us. Suppose this is having 4 sum matrices, which is B, C, E, D. Then how can I take a transpose of this? So generally, let's suppose I want to take the transpose of any matrix. So all rows of B, I mean, this B will get transposed, right? So which means let's suppose this is, you know, you can consider like this. This is, let's suppose for the whole matrix, this is first row, this is second row, this is third row, right? Now let's suppose this is B here, this is B here, this is C here, okay, this is C here. Suppose this is, okay, suppose this is E here. Let's suppose there are four rows, okay. Suppose this is E here, and suppose this is D here. Okay, so this is E and D. Let me make 4 rows. This is E, this is D. Okay. Now, if you take the transpose of this, then as you know that all of this row, okay, 1, 2, 3, 4 we have, then these will be columns only, right? So basically, what will happen is that this particular row, let's suppose this is 1, 2, 3, 4, right? And then 5, 6, 7, 8, then 9, 10, 11, 12, then 13, 14, 15, 16. Let's suppose this is our matrix. Okay. Now, if you take the transpose of this, then how will it look like? So it will look like this. If you take the transpose of this, then it will look like this, something like this. So let me just tell you that how it will look like. So maybe I can just put it aside. Okay. And then it will look something like this. So the transpose of this will become, this is 1, 2, 3, 4. This is 5, 6, 7, 8. This is 9, 10, 11, 12. This is 13, 14, 15, 16, right? Now, wherever this B is, let's suppose this is B, this is C, this is D, this is E. So what happened to B? See, isn't it B transpose? Check it. Isn't it B transpose? If this is B, then isn't it B transpose? If this is C, let's suppose this is D, this is E. So where is C transpose? Isn't it this C transpose? This one is C transpose, right? So this one is C transpose. Where is D? 11, 12, 15, 16. I think 11, 12, 15, 16 is here. This is, if you observe, you can just observe here. 11 and 12 are written vertically. So this is D transpose. And what about the remaining one? 9, 10, 13, 14, 9, 10, 13, 14. So this is E transpose, right? So what you can say, if PCED is the starting point, then what is the final point? If you take the transpose of this, then finally what you do, you transpose this internally also, which means BC and ED, right? ED. Okay. Will I stop on this? No. And individually also, okay, each. I mean, it is like internal. I mean, ऊपर से ट्रांसपोज करना है और हर एक मैट्रिक्स को भी ट्रांसपोज करना है. ओके. So it is like transpose, till the end, which means जितने भी layers हैं उन सब का transpose करना है, पूरे का, फिर हर एक का, right, like that. So we will be transposing all the layers. Okay. So I hope that is clear to everyone. Cool. So this is how we transpose. Now let's just go back to the question that where we started with this particular question, right? So they are saying, if you have something like this, right? If you have something like this, then tell me, is this case symmetric matrix? For example, if I just ask you, is this case symmetric matrix? Just tell me. So we can take the transpose of this, right? Okay. So what we can do, we take this K. So K transpose will be I, and then this A transpose, right? So I transpose is just I, then A transpose will be A, right? So this row here, and then individually transpose also. Then this is A 0 and individually transpose also. So 0 transpose is just 0. So basically I, A transpose and A transpose and 0 transpose. So finally it will be I, A transpose, A, and then 0. So is the same as the original one? The answer is yes. So that is why this is symmetric. So yes, symmetric. Okay, easy question only. Now tell me, is this true or false? So what they are saying, if you have some block matrix which is like this, if you take the transpose of this, then you will be getting something like this. Is this true or false? So what do you think? So I think this is true, right? You will be taking the whole transpose like this and then individual transpose also. So that's why it is true, right? What about this? Yeah, these are different questions. What about this? Yes, the whole transpose also, right? And the individual transpose also. So that's why this is also true. Understood? So these were just easy questions based on the transpose. Okay. Hope you got it. Now, let's see a special type of block matrices, which we call block triangular matrices, right? We call it block triangular matrices. So suppose we have something like this, right? Where one of the block matrix is just zero. Okay. This one of the block matrix is just zero. Then it is said to be block upper triangle matrix. Okay. So block upper triangular. Is this okay to everyone? Okay. Okay. So now, if you have something like this, where on the diagonal only you have non-zero, block matrices or non-zero sum matrices, then it is called block diagonal matrix. Okay. These are just names. For example, this is block diagonal matrix. Okay. Now tell me what kind of matrix this is. This is also the diagonal matrix, right? This is also block diagonal matrix. Now just tell me what kind of matrix it is. This is also diagonal matrix, right? What about this? If you just partition it, then this will be one partition, this will be another partition. I think this is upper triangular. Okay. Now let's see how to inverse a block matrix. This is little interesting or little complicated. I mean, both, right? I mean, this is little complicated also at the same time. If it is complicated, then that's why it is interesting also. So let's see this question directly. Okay, so this is one of the questions that we have directly to find the inverse. So what they're saying is that a matrix of this form, assume that A11 is P cross P, is it is Q cross Q, and A is invertible. Find the formula of A inverse. So they're saying if this is A, okay, then find the formula of A inverse. This is actually A. So whatever is the inverse of A, so if it is A, whatever is the inverse of A, if you multiply both, then you will be getting the this kind of answer, right? You will getting something like this. So this is just hint. As a hint, they have written it. So actually, we need to find out this A inverse. Okay. So what is this A inverse? This is the task that they're saying. Let's just see. Let's just see. So what we will be doing, we will be multiplying both, and then this must be equal to, after the multiplication, this must be equal to this identity block matrix, something like this, right? Okay. So if you equate all of these equations, so this must be I, this must be also 0, this 0 is 0 already, this is I, right? So these are the four equations you can write, right? Okay. So 1, this is 2, this is 3, A22, B21. Okay. A22 and B21. I think there is some typo. Let me just check. So this is A12, B21. That is okay. A11, B12, A12, B22 is 0. A22, B22 is IQ. Okay. A22. I think here instead of 0, it must be, let me just check. Yeah, A22, B21. It must be A22, B21. So this particular entry is A22, B21. I mean, which is eventually 0. So anyway, that's fine. So this is A22, B 21. Okay, cool. So now we have these four equations, which are something like this, right? Which are something like this. Now, what we want to do? We want to multiply, right? I mean, after the multiply, we got this. Now, if you equate these equations, I mean, these are the equations that we have got. That's very easy, right? Now, what you can do? You can make inference of this. So, which means if all of these sum matrices, all of these A's are invertible, then basically this B21 is coming out to be 0, this B22 is coming out to be A22 inverse, like this, right? And here, if this is V21 is 0, then V11 is coming out to be like this. And here, V12 is coming out to be like this if B22 is A22 inverse, right? This is A22 inverse, and A11 here, yeah. So basically it will be minus of this and then A11 inverse. So finally, these are the four equations we are getting. So basically what they are saying, if you want to find out the inverse of this, then you can multiply some matrix, some random matrix, such that it is identity ultimately, right? So if you do that, then you will be getting the values of all of this. You will be getting something like this. So this is the final answer that we are getting, right? So this is just one question where we have found out the inverse. Okay. So if you notice that because of this zero, we were getting a lot of help, in the sense that because of the zero, the calculations became little simpler. Okay. But it might be the case that zero might not be there, right? So I hope before I move further, this particular thing is okay, right? How to find the inverse of this? You multiply something like this. Let's call it A inverse. Then it should be identity block matrix. And then you can find out all of these values, right? Very easily. Okay. Now, suppose here, whatever thing we have found out, right? If let's suppose this A12 is 0, which means if it is a block diagonal matrix only, okay? If you put this A12 as 0, then this will be just 0. So if it is a diagonal matrix, then there is a special case. What is this special case? If it is a diagonal matrix, then if you want to find out the inverse, okay, of let's suppose some diagonal matrix, maybe let me just call it A0, 0. Let's suppose it is B. Okay, suppose this is P. Then what is a P inverse? For the diagonal matrix, it is actually very easy. This is A inverse, 0, 0, and B inverse. Okay, so that's what they are saying. If this entry could have been 0, then ultimately this A11 inverse and A22 inverse, right? The inverse is very easy in that case. Okay, if it is diagonal. Otherwise, let's suppose if it is upper triangular, then we did it in some other way. Okay. Now let's see this question. What they are saying. Suppose this is n cross n matrix A has this block form. Okay. Now where B is some P cross n minus P. Okay. And O is also n minus P cross P. Find the inverse of A in block form. So now they're asking you to find the inverse of A. What is the basic idea that we can apply here? The basic idea is that we will be multiplying with some matrix, and then we will be equating that to identity matrix. For example, okay, so the solution is not given. So let me just write the solution. So what we can do, we can multiply this given matrix, okay, which is I, B, 0, I, with some matrix, and then we can equate it to identity matrix. So let me call it PQRS, right? Is this okay? PQRS, right? Now it will be I into P. So P plus BR, right? It is Q plus BS. It is R. It is S. This must be equal to, since multiplication of this must be giving you identity matrix. So this must be equal to I 0 0 I, right? So R is 0. If R is 0, then you can put it at 0. Then P just identity matrix, right? Okay. So we need to find out the value of PQRS. Let's just go to the next page. So what are the values of PQRS? Let's just see. Okay. So let me write it here only. So if we compare P plus BR, or maybe you compare, I mean, we have got four equations, P plus BR equal to identity, Q plus BS equal to 0, R equal to 0, S equal to identity. So these two are very straightforward. If R is 0 and S is identity, if S is identity, Q is minus B, minus B. If R is 0, then P is just identity, right? So which means here PQRS, which means identity, Q is minus B, R is 0, and S is I, right? So that's how you can find out the inverse of this. Very easy question. Okay. Okay. Now, let's see this question, which I've taken from. So the source of this question is David Seeley. It is one of the very popular book in linear algebra. Okay. He's a author of this book. David Seeley is the author of this book, and his book is very popular for linear algebra. In fact, at ISC, professor recommend this book only. Okay, at even at ISC. Now let's see what they are saying. Show that this is invertible and finite inverse. So we need to find the inverse of this. Okay, I think this question I0 AI is the same as this I0 AI. No, this is something different. Okay, this is 0 here. Okay, so I think the question that I'm asking has 0 here and some matrix A here, right? So almost same question, little variation. You can say little variation, right? Almost same question. So I think you can do this question, and answer is definitely on the next page. So this is easy question only. You can try this, okay? Try this as a homework. Answer is on the next page. Okay, this is easy one only. Now, let's see this, what they're saying. If P is this, Q is this, with the block matrices, and A is M cross M, B is N cross N, possibly M is not equal to N, A and B both are invertible, show that P inverse is this. So we need to find P inverse, right? So how you can do it? Again, the same story. You multiply some random matrix, maybe you can say uh, D, E, F, G, or whatever, right? You multiply with some random matrix and make it identity, and then find out the value of D, E, F, G, right? Similarly for Q. So answer is again on the next page. Okay, you can assume this to be C, V, W, D, or something like that, right? And then find out the answer. Oh. Now, if you notice, then we have seen some special, kind of matrices till now to find the inverse. How? Here, if you notice, there is a 0. If you notice, there is a 0, right? Similarly, in all the questions, it is 0, identity. So some special kind of matrices we have seen, which means where the calculation is little easier, right? For example, in the first example, we had 0 here, right? We had 0 here. So because of the 0, the calculation was easier. Because of the identity matrices, for example, here we have the identity matrices. So that's why calculation was easier. Now, what if suppose we don't have any special case, right? Suppose we don't have any special case, which means that P is ABCD, and we need to find the inverse of this. Now, fortunately or unfortunately, this is extremely big calculation, and final calculation result you something like this. Okay, final calculation result to something like this. Why I said fortunately and why I said unfortunately is because unfortunately the calculation is bigger. Okay, how to calculate? You need to multiply some random matrix and then make it identity, and then find the values of for example X, W, Z, P, whatever, right? You need to multiply with this A, B, C, D, find the value of X, Y, Z, P. So if you do that, then calculation is very, very big, and X is coming out to be this and like this, right? Okay, unfortunately the calculation is big. Fortunately, even if the calculation is big, this is fortunately is that we don't need to remember this formula. Okay, so please don't remember this formula. This formula I wrote to show you that general case is not very interesting, right? So this is a general case that we have, but it is not very interesting. Okay, it might seem like interesting, but it is not, right? So basically we can find out inverse of a general matrix, but let's not do it. Even I can just say, okay, let's just cross it. Okay, let's just cross it. Okay, forget this, right? Formula. So just don't remember this. I just wrote it to show you that okay, it is not interesting. Now, we have seen the inverse, the how to find the inverse of at least the special matrices, right? I mean, the idea we have seen that we need to multiply by the some random, block matrix, and then we need to equate it to identity, and then we need to find the inverse. So this was the idea. Now, let's just see how to find determinant of the block matrices. Okay. For example, we have already seen this, so I'm not telling you in much more detail, because in the last class we have seen this, that if you want to find out the determinant of this, then if it is upper triangular, then it is a special case and it is A into C only, determinant of A into C. Okay, determinant of A into determinant of C. Right? Okay, this is I already solved. If it is like this, now suppose we want to find out the determinant of this. If it is upper triangular or lower triangular, it doesn't matter, right? In this case, it is upper triangular. So the determinant of this into determinant of this is the answer. Okay. So the determinant of this into determinant of this, right? This is the answer. But in general case, the more general case is something like this. Okay. I mean, if you have ABCD, if it is not upper triangle or lower triangle, then this is little complicated. Okay. So let's just let's just do one thing, because I have already told you these are the cases. So let's just do one thing. Let's just directly focus on the special cases. So what are the special cases? If it is lower triangular matrix or upper triangular matrix, then it is very easy. Okay. A into D only. Similarly, A into D only. If this is lower or upper triangular. Okay. Understood? Now, if you have, this is also one special case where if you have a matrix, a block matrix, such that this is AB, and then the next row, you have BA. I mean, instead of CD, you have BA. Okay. So this is also a little bit a special case, and here you have determinant of A minus B into determinant of A plus B, or you can also say determinant of A square minus B square, right? Okay. So how I came up with this, you can just see here. Okay, here if C equal to AB, BA, right? C equal to B and D equal to A, then you will be getting the same thing. Okay, you can put C equal to B and B equal to A, right? So it will be D minus C, and determinant of A into determinant of D is basically A, right? So it is A minus C is B, B, A inverse, B is B only. Okay. So now you multiply by the A. Okay, so A minus, or maybe let me just try with this. This D is A, right? So this is A minus B. D inverse means A inverse B. Okay, so it is A into A minus B, A inverse B. So it is A square minus AB, A inverse B. Is this B square? This is B, A inverse, this is B, A inverse B. Okay, so if AB and BA commute, right, then it is okay. But even if they don't commute, then also it will be like final answer will be same. So actually, there is one more proof. So let me just tell you the easier proof only. So basically, we want to prove this, right? So yes, if you put those values in the general case, then also you will be getting the same thing, right? Or otherwise, what you can do, you can take this and then you can apply elementary column or elementary row operation. Okay. So column operation means you're applying the row operation only, but on the transpose of this. I mean, transpose this matrix. Anyway, so what you can do, you can apply elementary column operation. Determinant doesn't change. So if you do this, then elementary row operation, then it is like this. For the upper triangular, as you know, it is determinant of a plus b into a determinant of a minus b. So this is one other way to prove it. Okay. Anyway, the proof is not necessary. I'm just telling you there are two special cases. Okay. If it is lower triangle, upper triangle, then determinant is GG. If it is AB, BA, then also determinant is EG, which is determinant of A minus B into determinant of A plus B. Okay. Actually, this case has been asked in GATE CSE. Generally, they don't ask you to mug up the things. They don't ask you to do something like this. But this case has been asked in GATE CSE, and this is also mentioned at various other websites. So that's why I'm just telling you this case. Okay. So anyway, we will see this again. I mean, with the examples. So let's just do this. So what is the determinant of A here? This is a very easy. Determinant of A here is determinant of B into determinant of E, right? Okay. What is the determinant of this? See here, this is one block, this is another block. So determinant of this is determinant of this into determinant of this. Okay. So answer I don't have, but yeah, it will be determinant of 2405 into determinant of 4114. Okay. So anyway, it is just like AB, BA. So it will be A square minus B square, right? So it will be 16 minus 1. So it is 15 into it is 10. So it is 150. Okay. If you do this also, you will be getting 150 as an answer. I mean, do without the using block matrix properties. Okay. You will be getting 150 as an answer. Now determinant of A will be, since it is a diagonal matrix, block diagonal matrix, so it will be just determinant of A1 into A2 into determinant of A3. Okay, now let's just see what is the determinant of this whole matrix. This is one matrix, this is another matrix, this is another matrix. So this is the upper triangular matrix. So that's why determinant will be just the determinant of this into determinant of this, right? Okay. So you can do it. It will be determinant of B into determinant of E, right? So this is, I think this is B, this is E. Okay. C and D doesn't really matter here. D is a zero matrix only. Okay. Consider this. Compute the eigenvalues. So now the things are little different. Now they're asking you to compute the eigenvalues instead of determinant. Okay. Let's just see. Let's just see if you can do this. This is really interesting. See, computing the eigenvalues actually also require you to find the determinant, right? Okay. So what you can do, you can basically let me just go to the next page. What you can do, you can do A minus lambda I, right? I means here from the all of this diagonal, you will be subtracting the lambda. So it will be basically something like this. Actually, from the diagonal only, you will be subtracting the lambda. So it will become minus lambda, minus lambda, minus lambda, minus lambda. And you want to find the determinant of this, right? So it will be determinant of this into determinant of this, isn't it? So it will be determinant of 3 minus lambda minus 1, 1, 1 minus lambda into determinant of 3 minus lambda minus 1, 1, 1 minus lambda, right? So what is the answer? This will be 3 minus lambda into 1 minus lambda. And then I think this is 3 minus lambda into 1 minus lambda. And then this is plus 1, right? Plus 1. This is the determinant of this. And then determinant of this is 3 minus lambda into 1 minus lambda. Okay, these are the same matrices, right? Cool. So this is just a square of this, okay. Anyway, this is the same matrix, so it is just a square of this, right? So equal to 0. So I think this is the same matrix. 3 minus lambda, 3 minus 1, 1 minus 1, 3 minus 1, 1, 1. Okay. So these are the same matrices. So basically, if we want to find out the determinant of this whole thing, it will be determinant of this into determinant of this. Okay. Now, the final characteristics polynomial you have got is something like this. Let me write it. The polynomial that you have got is basically plus 1 square equal to 0, right? Okay. Now, from here, can you solve for the values of lambda? So what you can do, this is 3 minus lambda into 1 minus lambda plus 1 equal to 0, which is equal to minus 1. And then I think this will be the quadratic equation. Then you need to solve the quadratic equations, right? So 3 minus lambda. Okay, you are getting quadratic equation is lambda minus 2 over 4. So actually, if you solve this, then I think this is lambda minus 2 square. Okay, if you solve this, if you can even solve this internally, it is lambda minus 2 square. Okay. Yeah, I think this will be lambda minus 2 square because this is 4, this is 3 plus 1 is 4. Okay, so ultimately it is lambda minus 2 power whole power of 4, right? Because square I'm getting here. Okay, so I hope you understood
I didn't get that. Could you try again?
So I hope you understood that lambda minus 2 power 4 equal to 0 is your characteristics polynomial. So what are the eigenvalues? Lambda equal to all 2's, right? Lambda equal to 2 comma 2 comma 2 comma 2. These are the eigenvalues. Okay. So how did we find the eigenvalues? Using the properties of the block matrix. What is the property that I have used? That since it is a diagonal matrix, so if I want to find out the determinant of this, right, then this is just a determinant of this into determinant of this. Okay. This is the property where we have used the block matrix property, right? Block matrix property. So basically, the eigenvalues is also the you can say finding the determinant only, but for the another matrix. Okay, and what is the matrix? Instead of finding out the determinant of A, we don't find the determinant of A here. We find the determinant of A minus lambda. Okay. Okay. So find this using properties of block matrix. Okay. Now let's just see the next question. So now what they're saying here, consider the block matrix A, which is defined like this, where all the submatrices B, C, D are of the same size, which of the following statement are true regarding the eigenvalues of A. Again, they're asking the eigenvalues, right? So basically, if you take this block matrix, right? If you take this block matrix, and if you subtract minus lambda I from here, then actually we have noticed if you subtract minus lambda I from here, then this will be just, you can say it is B minus lambda I only, right? And then C will be as it is, this 0 will be as it is, this D minus lambda I. Obviously, this will be, some dimension, let's suppose n, then this is P, this is n minus P or something like this, right? Okay, but let's not worry about the dimensions. Okay, so this is A minus lambda I. This matrix is A minus lambda I. Now, if we want to find out the determinant of A minus lambda I, then what will the determinant? It will be B minus lambda I, determinant of B minus lambda I into determinant of D minus lambda I. Okay, which is 0. So basically, determinant of A minus lambda I is coming like this, right? It is coming like this. Now, whatever is the eigenvalue of B, it will satisfy this determinant of B minus lambda I must be 0. I mean, if I put, let's suppose eigenvalue of B is lambda B. If I put lambda B here, will not be 0, right? For all the lambda B's, which means if lambda B is the eigenvalue of capital B, then if I put the lambda B here, it will be 0. Similarly, if I put the lambda D here, it will be 0. So all the eigenvalues of B and D are satisfying this, isn't it? See, you have got some equation like this, right? If you do A minus lambda I, okay, if you do A minus lambda I, then you have got some equation like this. Now they're asking you to find out the eigenvalues of A, which means you solve this, right? What does this solving mean? It means that determinant of B minus lambda I is either 0 or determinant of D minus lambda I is 0. It means lambda equal to lambda B. I mean eigenvalues of B. It means lambda equal to lambda D. Matlab eigenvalues of D. So all the eigenvalues of B and D are the eigenvalues of A. And eigenvalues of A, and vice versa also, eigenvalues of A is either eigenvalue of B or eigenvalue of D, right? So I can write it here. All the eigenvalues of A equal to eigenvalues of B union eigenvalues of D. Understood? Okay. So basically, this is how you can understand this, right? So what was the question? They are saying if this A is given, then which of the following statement are true regarding the eigenvalues of A? So what is true here? Eigenvalues of B are also eigenvalues of A. Is this true? Then the answer is yes, this is true, right? So this is true. So I can say this is true. Eigenvalues of D are also eigenvalues of A. Eigenvalues of BD, B into D. No, that has no relation. Eigenvalues of B plus D. No, that has no relation. Okay. So I hope this question is understood to everyone. That what they are trying to ask. Okay. Cool. See here that only if you subtract the lambda I, it will be subtracted from the diagonal only. And then it will be just like this. So thus the eigenvalues of B and D are also eigenvalues of A. Now let's see this question, which I've taken from Stack Exchange. What they're saying, it is known that B and C, B, C, D all are 3 cross 3 matrix. B is having some eigenvalue 1, 2, 3. C is having 4, 5, 6. D is also having some eigenvalue 7, 8, 9. Then what is the eigenvalue of this matrix, this block matrix? Can you tell me? Just now we have seen something like this, right? Just now. So just try to tell me what is the answer here. So, okay. So I think we have got one answer from Partha Sarthi. So what he's saying, 1, 2, 3, 7, 5, 9, 7, 8, 9. Okay. So let's just see. Let's just see if this is correct. Okay. Let's just see. So see here, the eigenvalues of this particular block matrix will be the eigenvalues of B and the eigenvalues of D, right? So it must be because it is B minus the determinant will be, see, if you consider this as A, then determinant of A minus lambda I will be equal to determinant of B minus lambda I multiplication with determinant of D minus lambda I, right? Which is 0. Okay. So which means eigenvalues of B, which means these, and eigenvalues of D, right? So 1, 2, 3, and 7, 8, 9 should be the answer. Okay. So yeah, answer I don't have, but this question I have taken from Stack Exchange. Okay. It is easy and nice question. Interestingly, you can see that most people find it very interesting and tough also. That's why there are 23 upvotes on Stack Exchange, which is a very, very good number, right? 23 upvotes on Stack Exchange is really a very good number. So this was, one of the very interesting question to many people, one of the very tough question, difficult question, and we have easily solved it. Why? Because we had our background ready with us. Okay. Now let's just see this question, which I have taken from David Seeley. Okay, so it is also easy question. The answer of this question on the next page. So that's why you can take this as an homework because answer is already there in the next page. Okay. Now let's see this question. This question again I have taken from Stack Exchange. Let's just see what they're saying. Suppose let A be n cross n real matrix, which is and let this is C, which of the following are true. You find out the eigenvalues of this C, okay? And let's just see that how they're related to the eigenvalues of A and B. So this is little nice question. So what they're saying, find out the eigenvalues of C. Now you tell me what will be the C minus lambda I here? This will be A minus lambda I, B, B, and again A minus lambda I. We need to find out determinant of this particular matrix, right? Determinant of this particular matrix. This matrix is actually, I can say, very, familiar to us. Why? Because we have already seen one special type of matrix where see, it is not possible to find out, to basically remember the general formula. So that's why the special case I can remember, which is if this is AB and BA, then the determinant is A minus B into A plus B. Okay. Or otherwise, you can, sum both of this. This will be A plus B only, right? A plus B, A plus B, BA. Then you can probably subtract one from another, right? It will be 0. It will be A minus B, right? A minus B. So it is A plus B into A minus B. This is how the determinant you can find out. So anyway, if it is something like this, A, B, B, A, then the determinant is A minus B and A minus B into A plus B. So basically, can you tell me what is the determinant of this? If this is A minus, A, B, B, A kind of thing, then it will be determinant of A minus lambda I, this is the first matrix, minus B into determinant of A minus lambda I plus B. Tell me if that is okay to everyone. Okay. Now, what they're saying in this question, that they're saying, okay, how the eigenvalues of the C and the eigenvalues of A minus B and A plus B are related. So I hope this is fine to everyone, right? So which means, just a second. Okay, sorry. Yeah. So now you tell me how they're related. See, this is nothing but, this particular thing is nothing but A minus B minus lambda I. You just consider this as a just one matrix, right? Into determinant of A plus B minus lambda I. Right? You just consider this as also as just one matrix. Now, what you can say about determinant of C? Sorry, the eigenvalues of C. Isn't it the same as eigenvalue of A minus B and eigenvalue of A plus B? Right? So the eigenvalues of C equal to eigenvalues of A minus B and eigenvalues of A plus B. Okay. This is also interesting and nice question. So if lambda is eigenvalue of A plus B, then it is eigenvalue of C. Yes. If it is A minus B, then it is eigenvalue of C. Lambda is eigenvalue of either A or B. No. For A or B, it is not related. Right? So this is false. All eigenvalues of C are real. Yes. If they're real matrices, then the eigenvalues of C will be real. Okay. So this is also true. So what is the answer? Only C is false. Okay. Option 3 is false. Okay. 1, 2, and 4 are true. Now let's just see this particular question. What they are saying, that can you find out the eigenvalues of this particular matrix? I think this is easy. What is the answer? The eigenvalue of this matrix and the eigenvalue of this matrix, isn't it? Okay. So determine the eigenvalues of this 4 cross 4 matrix. That is the question basically. Okay. So the question is that can you find out the eigenvalues of this 4 cross 4 matrix? So what is the answer? Yes, that's easy. How? It is the eigenvalues of this and eigenvalues of this because it is block diagonal. Okay. So it is like this, then it is the eigenvalue of B and eigenvalue of C. Okay. Find out the eigenvalues of this. Can you do this? See here. It is it a block matrix? Yes, right? This is also the block matrix. So eigenvalues of this and eigenvalues of this. Isn't it? So this is one block, this is another block, this is another block, and this is another block. Okay. So you can find out the eigenvalues of these two. This and this. Now they are saying consider these two and find out the eigenvalues and eigenvectors, right? Okay. Now let's just see one thing. Let's suppose, see, eigenvalues I told you how to find out. But let's just see about the eigenvectors also. It is also easy, but let's just see this. Suppose A is something like this. Okay. Eigenvalues I can find out. How? Using this and this, right? But what about the eigenvectors? See here. Let's suppose, okay, here there is some other matrix. Assume 3 minus 1, 1, 1, 3 minus 1, 1, 1. Okay. So maybe, I mean, let's just assume this is some matrix, some submatrix, right? Let's just assume eigenvector of this, 3 minus 1, 1, 1. Eigenvector of this is maybe x1, x2. Okay, just assume this. Okay, for example, for the sake of, just example, let's just say this is some other matrix, maybe 3, okay, or maybe 2. This is some other matrix, okay. I don't want to have same matrix to give you some example, okay. Let's suppose this is 2. Suppose the eigenvector of this is x1, x2, and eigenvector of, let's suppose, and assume eigenvector of the another matrix 3, 2, 1, 1. Let's suppose the eigenvector is something, maybe x3, x4, or y1, y2. Maybe let's suppose y1, y2. Okay. Then what is the eigenvector of this? Interestingly, the eigenvectors are taking this form. See here, this is x1, x2, 0, 0. Okay. Suppose you partition like this. Okay. You already partition like this. Here, if you're partitioning this, let's suppose by after 2 columns, then it is after 2 rows, and then you can partition like this. Okay. Suppose this is the partition. Then this will get multiplied. This particular will get multiplied with this, right? And 0, 0 anyway will 0, 0, right? So what is the answer? This will get multiplied with this. So this matrix is getting multiplied with its own eigenvector, isn't it? So it will be lambda into x1, x2, isn't it? Plus 0, right? Plus 0. And this will get multiplied with this, which is 0. This will get multiplied with this, which is 0, right? So this is basically, if you multiply actually these, then you will be getting x1, x2, right? 0, 0, and lambda will be here. So you can take the lambda out, and then this is the answer. So which means, you can take just lambda one time out. So this is here, and then finally you can take the lambda out. Understood? Okay. I hope that is okay to everyone, that how we are doing it. Okay. So what you understood here is that if you multiply with this vector, then finally you are getting lambda into the same vector. So can't I say this is the eigenvector? Tell me. I can say, right? So finally I can say this is the eigenvector. Similarly, interestingly, if you multiply, okay, if you multiply, let's suppose if you multiply by 0, 0, by 1 by 2, suppose, okay, the eigenvector of this. So assume you multiply by 0, 0, and here you have by 1 by 2. Then you can easily verify that it will be something like this. Okay. So which means what is the answer? If you do something like this, let's suppose this is by 1 by 2. This will be by 1 by 2. This will be 0, 0, by 1 by 2. This will be 0, 0, by 1 by 2. What I mean to say is that if you multiply this, then this will get multiplied by 0. This will get multiplied by anyway 0. 0 will get multiplied by 0. Only this will get multiplied by this, which is lambda into this, because I'm assuming the eigenvector is this, right? So basically, if you know the eigenvectors individually of this, if you know the eigenvector of this, then ultimately for this diagonal matrix, right? Ultimately, the eigenvector of the whole matrix will be of this form. What form? X1, x2, 0, 0, and y1, y2, 0, 0. Sorry, 0, 0, y1, y2. Okay. Hope you understood, right? Okay. So now we know for the diagonal matrix at least how to find out the eigenvalues, how to find out the eigenvectors. Eigenvectors are actually just easy. You just need to append 0, 0. Okay. So for this, I can find out eigenvalues and eigenvectors. For this, at least the eigenvalues I can find out because it is upper triangular. So I know how to find out the eigenvalues. Eigenvector is little interesting. So you just try to find out the eigenvector of this. Okay. Maybe I can do this. So let's just try to find out the eigenvector of this. See, for the diagonal we have seen, but for this, let's just see. Let's suppose eigenvector of the first is x1, x2 only. Okay. So it is x1, x2, 0, 0. Ultimately, what I'm looking for is lambda into, the same thing, x1, x2 or something like this, right? Let's just see that what we get. Okay. Ultimately. So this will get multiplied by this. So this is lambda into x1, lambda into x2. This will get multiplied by 0. This is 0. This is 0. Okay. 0, 0. So for this, it is okay, which is lambda into x1, x2, 0, 0, which means we have got eigenvector as same. Okay. Which means whatever is the eigenvector of this, you append 0, 0, you will be getting the eigenvector of the whole thing. Now, what about the other eigenvector? Which means, what about the eigenvector of this? Which means if we multiply 0, 0 by 1 by 2, is this eigenvector? Let's just check. Okay. Let's just check. So this will get multiplied by this, which is 0, right? This will also, and this will get multiplied by this. This is interesting. So if this and this get multiplied, what is the answer? By 1 times this, which is just by 1, and by 2 times this, right? So I think 0 by 1. So finally, 0 by 1 will be here. And this will get multiplied with this. This is 0. This will get multiplied with this, which is, lambda into by 1, lambda into by 2. Okay. You are getting this. Now, obviously, you can't just take the lambda out, right? Just like the previous case. So what we can do here? So let me just tell you the values of y1, y2. I mean the eigenvectors of this another matrix. Okay. So by using the for the first matrix, I have two eigenvectors. Okay. So we cannot take this lambda out here, right? So y1, y2 values are actually not known, but anyway, that's fine. So you can't take this lambda out. So basically, whatever is the eigenvector here cannot be just, lambda 1, lambda 2 cannot be just the eigenvector after appending 0, which means this 0, 0, y1, y2 is not eigenvector, right? Is not eigenvector. This is not eigenvector. Because if this could have been eigenvector, okay, not eigenvector, assuming that this by 1 is not 0, okay, If by 1 is 0, then it is easy. But assuming, okay, by 1 is not 0. Which means if this by 1 is not 0, there's some non-zero term, then you can't take this lambda out, right? So this is not eigenvector. So for this next matrix, only x1, x2, 0, 0 is eigenvector, okay? That's what they are saying, that only x1, x2, 0, 0 is the only eigenvector, right? Okay. Now let's just see this question. Find the eigenvalues of this matrix. I think you can do it, right? This is the block matrix, you can do it. So 2 minus r, 5 minus r. So basically it is 2, 5, and then eigenvalues of this. So eigenvalues of this. Okay, I think we have already done this. We have found out the determinant of this, but not the eigenvalues. Okay. So anyway, the eigenvalues are coming 2, 5, and 5, 3. Okay. ठीक है. Now find the eigenvalues of this. Is this a block matrix? So this is okay. This is okay, right? So basically, you can find out the eigenvalues of this. You can find out the eigenvalues of this. So they have separated it out. Okay. B1, B2, B3 are 2 cross through 2 matrix. B1, B2, and B3. 0, 0. Okay. So sorry. This is 3 cross 3. Yeah. We can find out like this, but I think they have done it, little more. They have done it little more. So in this solution, they have actually, in this particular solution, they have done it little more. I think they're saying this is one block. This seems to be, I mean, they're partitioning like this. Okay. This is kind of another block. And then but what is the benefit of this? Or maybe you can just partition like this only. Okay. This is fine. Okay. So if you want to find out the determinant of this, then again, I think they're partitioning. You can partition this. Okay. Find the eigenvalues of this, and 3 is like just like a eigenvalues. Okay. So you can again partition. So which means if you want to find out the eigenvalues of the whole thing, then it is the eigenvalues of this and the eigenvalues of this, right? Then the eigenvalues of this and the eigenvalues of this. Now to find out the eigenvalues of this, you can again partition it, right? Then it is nothing but, if you want to find out the determinant of this, it is nothing but determinant of this into determinant of this, which is just 3 minus lambda. So they have again partitioned it. Okay. So anyway, you can do this, and the answer is on the next page. Okay. Cool. Now these are the few questions. Now they are saying, consider this block B. How can we find the eigenvalues lambda B? Okay, so you need to find the eigenvalues of B in terms of the eigenvalues of A. So which means it will be A minus lambda I into I A minus lambda I. Do you remember this kind of formulation? If you want to find out the determinant of this kind of block matrix, then it will be A minus lambda I minus I, right? And A minus lambda I plus I. Right? So let me go to the next page. Okay. Lambda A square minus I. Yes, something like this, right? Lambda minus I whole square minus I. Yes. So let me go to the next page. So basically, this is a matrix which is given to us. Then they're saying what is the eigenvalues of B in terms of the eigenvalues of A. Okay. So what is B minus lambda I? B minus lambda I is coming out to be A minus lambda I A minus lambda I. Okay. Then this is nothing but, the determinant of this is nothing but determinant of the first matrix A minus lambda I minus the second matrix into determinant of the first matrix plus the second matrix. Now, can you write this? Okay, can you write this whole thing? Can you try to write this whole thing as a determinant of some matrix, okay, minus lambda into some matrix. Sorry, minus lambda I, not just random matrix. So basically, I can write like this, right? Minus I into, or maybe lambda, I can take I common, or maybe, right? This will be lambda plus 1. Yes. So you can take I common, then it will be lambda plus 1. Isn't it? Similarly, it will be determinant of A minus, you can take I common, it will be lambda minus 1. Okay. Now, from here, what we can say, okay, from here, what we can say, just think about it. See, we have got this, which means, let's suppose lambda v are the eigenvalues. So we have got this, right? This and this. If you take the I common, you will be getting this. So basically, as you know, that if you write like this, maybe I hope till now it is fine, right? Now, as you know, that determinant of A minus some lambda A into I is equal to 0. You know this, right? Similarly, okay, determinant of, yeah, I mean, this is if lambda, so you can say if lambda A is eigenvalue of A, then this holds, right? Okay. Now from here, what we can say, determinant of A minus lambda B plus 1 into I equal to 0, or determinant of A minus lambda B minus 1 into I equal to 0. Okay. See, maybe you are getting it, but let me just tell you in more detail. See, what is happening here is that you are having basically B minus lambda I. Now you expand B minus lambda I, then you got something like this. Okay, if you expand B minus lambda I, from here, what you can say, this lambda B plus 1 is nothing but lambda B plus 1 is nothing but some lambda A. I mean, this is the eigenvalue of A, right? This is the eigenvalues of A. So lambda A. Similarly, lambda B minus 1 is also some lambda A, which means lambda B is nothing but lambda A minus 1, and lambda B, I mean, some other eigenvalue of B is lambda A plus 1. So which means whatever is the eigenvalue of A, if you subtract 1 from that, right? If you subtract 1 from that, and then you put, instead of lambda B, you put that, then it will be, let's suppose the eigenvalue of A is 5, right? What does this mean? A minus 5i should be 0. Then can I say the eigenvalue of B is 4 also and 6 also? Why? Because if you put, okay, if you put 6, then if you put 6 here, then isn't it making the whole equation 0? Because this is 0, right? If you put 4 here also, then isn't it also making the whole equation as 0? So which means if lambda A is 5, then lambda B is 4 also and 6 also. You can subtract 1 and add 1. And finally, you will be getting the eigenvalues of B. Okay. So what are the eigenvalues of, so they are saying, then how can we find the eigenvalues of B in terms of the eigenvalues of A? So eigenvalues of B are nothing but whatever is the eigenvalue of A, you do plus minus 1, both. Okay. So this question is actually very, I can say, interesting, very difficult also. Okay, at the same time. Now, if that is the case, then let's just let's just see one of the gate question that they have asked. This is the similar gate question. Okay, as you can see, there are 81 upvotes. This is gate CSE question which has been asked in 2007. Just try out this question. Okay, exact same question, AIIA. Okay, here also AIIA. So they are saying if the lambda or the eigenvalues of A are given, then which is 5, -2, 1 and 4, then which of the following is the eigenvalue of this matrix? You add one also and subtract one also. So 4, from here you can say 4 and 6. From here you can say -1. If you add 1, if you subtract, -3. If you add 1, 2. If you subtract, it is 0. If you add 1, this is 5. If you subtract, it will be 3. So these are the eigenvalues, right? Is -5 here? No. Is -7 here? No. Is 2 here? Yes. Is 1 here? No. So 2 is the answer here. Okay. So this was, I can say, this was one of the very difficult questions. That's why on gate or flow also there are 81 upvotes. Okay. But if you have understood the block matrices, only one question has been asked till now. Okay, maybe the reason is that because it requires a lot of block matrix. You can say the properties and on all of this, right? Okay. Now there are other questions. They are saying find the determinant of this. So what you can do, you can just partition this maybe like this. Find out the determinant of this. Find out the determinant of this, right? Okay. Let's just see the answer. Yeah, partition into 4 cross 4 matrix and 2 cross 2. So it is 4 cross 4, partition like this, into 2 cross 2. Okay. So now the similar kind of question, find out the, I think we have already solved it, right? This eigenvalues, we have already solved it. So let's not worry about it. Okay. So these are the questions in this block matrix. And that's all about the block matrix that we had, right? Now, I hope you got the proper idea what are the block matrices, how to find the eigenvalues, eigenvectors like this. I mean, in special cases, it becomes easy. Otherwise, there is no use of doing the block matrix itself, okay? If it is not a special case, right? So now you should not be, actually the idea of the block matrix is that you should not be afraid of this topic, which means whenever you are seeing the partitions, blocks, you should not get afraid, right? That's why it was important to tell you the whole topic as a particular lecture. I hope you liked it. If you liked it, then you just let us know in the review. Okay, so just let us know that how much you like this linear algebra. Okay, thank you so much. So we will just put a review. You just let us know in the review. Okay, or if you're watching this on the YouTube, you can just let us know in the comments also. Okay, please do comment so that we also get to know that how you're liking the subject. Thank you, everyone. Thank you so much. Take care. Bye bye.